So in this problem, they give you x1 equals 25 and x2 equals 26. So in order to find the change in the stopping distance, you need to do y2 minus y1. So your formula is t equals 2.5x plus 0.5x to the power of 2. So that's your formula. So in order to find the change, you need to plug in your x2, that is 26, into your formula minus the formula with the x1 plugged in. So it goes like this. It is t equals 2.5. Then you plug in the x2, that is 25, plus 0.5, 26 to the power of 2. Then you close the parenthesis and you do minus your formula with the 25 plugged in. And that will give us 28. And that is your change in the stopping distance.
Problem 1b.
To find the percentage of the change, we can use this formula. y2 minus y1, parentheses, divided over y1, close the parentheses, times 100 will give us the percentage. So we need to remember things from our past exercise, which are this. We need to do y2 minus y1 will give us 28. So 28 over y1 is 28 divided over 2 and close the parentheses. Is the same as 0.0746666. So we're gonna round up to 0.075. Then we need to multiply it by 100. So times 0.075 times 100 is 7.5. 7.5%, and that is the percent of change.
So for this part of the question, we're asked to find the approximation to the percentage. So we're going to do the same as we did when we found the change in percentage. And so we're going to put a 27.5, which was approximation to the total stopping time, which was 27.5. And we're going to do the same. So we're going to divide it over 100, and then we will get 0.275, and that we will multiply times 100, and that will give us 27.5%. And if we compare it to the original percentage, it will give us a difference of 0.5%. So as we may see, what the percentage is telling us is that from the original percentage and this one, we have a variation or also called an error of 0.5. Okay, so in the number one, for the letter C, they're telling us to approximate the change in percentage in total stopping distance as speed changes from x equals 25 to x equals 26 miles per hour. But first, we know that the change in stopping time is 20 feet and the percentage change is 7.467%. So, for this problem, we first need to derivate the equation given to us, which is t equals 2.5x plus 0.5x squared. Now, for us to derivate this, we're going to change the t into dt because it's a derivative, then 2.5 plus x. Because if we take the 2 and place it in the front and multiply, it will give us 1, an imaginary 1, and then we subtract 2 minus 1 and is 1, which is x. Now the next part is for us to substitute. And for it, we know that our speed is changing from x1 equals 25 to x2 equals 26. And the dx, which means that change in the x's, the change in speed, equals 1, because if we subtract 26 minus 25 equals 1. So now we're going to place, besides the x, we're going to put dt equals 25, no change for the 25 because there's no x, times x times dx, plus x times dx. Now, we know that the x's have to give us 26. So we know that 25 plus 1 is 26. And it has to give us 26. So we're going to place the first x where the x is, and the dx, which is the change for us to get 26. So it is correct. Now we're just going to substitute this equation, which is dt equals 25 plus x, which is 25, because it was our first x, times the x, which means the change in the speed, and that's it. Now we're just going to solve it. 2.5 plus 25, and this would give us dt equals 27.5 feet. Meaning that our approximation to the change in stopping time is 27.5 feet, which is really close to the real change in stopping time, meaning that it was correct. We need to divide each term by the denominator. So we will have and also you can make this look nicer by putting 8x to the 2/3 in order to be able to do the problem more fast. So you will put the antiderivative of everything divided by the denominator, and remember to always add times dx. Now we're going to simplify.
So we will be left with antiderivative of 1, since this will become 1, times. We are subtracting the exponents here. After this, we are going to now start antiderivating. So we will have 1x plus 6x to the third. We always add to the exponent on the top, we will add 1, and then the number we get, we will divide it by everything. So to this fraction we add 1, and this will be minus 4 over 3. And also the whole term will be divided by the same term. And since we are already antiderivating, we will need to add plus c. And we will no longer add the antiderivative sign since we are already antiderivating. And now we're going to simplify this term. So we will be left with 1x plus 2x to the third, and these two negatives will become a positive 6x negative 4 over 3 plus c. And we don't want to be left with a negative exponent, so we will simplify again. And this will be our final answer.